Hello, my name is Mark Hatfull. This is the Theoretical Revolution. This is a series of video tutorials where I try and discuss a unified theory, my unified theory. These videos will simply and methodically go through a series of talks discussing a simple unified theory and how that unified theory shows all the observed phenomena of the universe. This is the first video, which I've called the Unified Theory. This video gives a quick introduction and then basically talks about a simple concept or idea without going into too much detail on the unified theory itself. So video 1, this is the first video of a series of videos. This video explains a basic concept, and using this concept I'll go on to explain all the observable phenomena of the universe. So other videos, this video cannot explain everything. Unfortunately, it's a big topic, there's a lot to explain. I can't do that all in one video, so subsequent videos. This one just describes a brief concept without actually going into the unified theory itself. Other subsequent videos will look at the universe, how the universe was created, the shape, movement and distribution of mass through the universe, and the time course and lifespan of the universe itself, as well as looking what it was like before and after the universe was created and what's outside our universe. I'll talk about space and the composition of space-time, how it makes up our universe and how it behaves and the characteristics of space-time itself. I'll then go on to talk about light, whether light is a particle or a wave or both, why the speed of light appears to be constant, and how it manages to travel at a constant speed. I'll go on to talk about time, talking about the properties of space-time, how light, gravity and relative movement all contribute to the progression of time, and why time is affected by gravity, light or by relative motion. Then one of my favourite talks is the talk of gravity. I'll talk about how my unified theory identifies what gravity is, how it works, how it behaves, and basically break down gravity piece by piece so we know exactly what it is. I'll also talk about in the subsequent videos other concepts like dark energy, dark matter, what they are, what they're made up of, how they work, and possibly even how to create our own dark energy or dark matter. And then I'll talk about other phenomena and theories that we also observe, the formation of galaxies, Einstein's unified theory, Einstein's theory of relativity, and other phenomena that we observe in the universe, and how my theory, the unified theory, relates to those phenomena and explains them or is proven by them. Alright, so there's a lot to talk about, so let's get started. The unified theory. I believe I've come up with a simple theory that can help us understand all observed phenomena in the universe. This theory is incredibly simple. There are no complicated concepts, there's no extras, there's no exceptions to the rule. It explains all phenomena, explains why all phenomena behave the way they do, and there's no exceptions or phenomena that aren't explained or what ifs or buts. So, and also this theory only uses basic, simple elementary physics. The principles are all already proven and already well known and can be easily replicatable in any classroom, science lab, or read about in any basic secondary school textbook. And most importantly, it wouldn't be a unified theory unless it explained everything. So this theory explains all observable phenomena in the universe itself, space, time, gravity, dark energy, dark matter, explains it all. There's no exceptions to the rule. There's nothing that isn't explained by this theory. So let's start from the start. Let's look at current theory. What do we already know? Well, the answer to that, not much. So we know there is a universe, but we don't know how it was created, or we don't know where it came from. We don't know its size or shape. We don't know whether it's finite or infinite. We don't know what is outside our universe or what it was like before our universe was created. We don't know if there's going to be an end to our universe or what it'll be like after our universe is gone. In fact, inside our universe, we don't know whether we are moving or what direction we're moving in or whereabouts in our universe we are. So, we know that the universe is expanding, but we don't know how it's expanding. We don't know why it's expanding. We don't even know what we're expanding into. We don't even know what direction we're expanding into. And we don't know how fast we're expanding into it. We know that there is gravity, but we don't know what gravity is, and we don't know how gravity works. We have no accurate current theory for gravity. We know that the speed of light is constant, but we don't know why it's constant, and we don't have any idea how it could possibly be constant. We know that time slows down with velocity or gravity, but we don't know why or how this happens. In fact, why would gravity, an attractive force between two objects of mass, affect time, a variable that doesn't have any mass? We know that there is dark energy and dark matter, but we know nothing about them. We do not know what they are or even where they are, and we do not have any idea how they work. So, in summary, we know a few things, but we don't know much. We only have a few small pieces of the puzzle. Currently, they all seem to be complicated and apparently unrelated. We have multiple theories explaining individual phenomena, but no single theory explaining all phenomena. So, somehow all these pieces of the puzzle fit together and make up the big picture, and that big picture is a single unified theory. I believe that I have this theory. I've come up with a single theory which explains all phenomena, a unified theory. So, I believe I've come up with a single theory that explains every question from the previous slides. It explains the universe, why the universe was created, how it was created, what the shape of the universe is, the movement of the universe, and its lifespan and time course. This theory can explain gravity, how gravity works and why it works. It explains light, the properties of light, why the speed of light travels at a constant speed, and how it is possible for it to do that. It explains space-time, the properties of space-time and how they behave, and why they are altered by light, gravity, or relative movement. It also explains dark energy and dark matter, breaking down what they are, where they are, and how they work, and all other observable phenomena in the universe. So, what my theory can't do? Well, my theory can accurately explain every phenomenon in the universe, but what my theory cannot do is agree and be consistent with all current theories. There are so many current, complicated, incomplete, unrelated, or inconsistent theories that it is not possible for anyone to combine all of these theories into one single, simple theory. Therefore, it is impossible for all of these theories to be accurate simultaneously. Some of them must be wrong. If you're not willing to believe that some of our current theories are incorrect or inaccurate, then you're not willing to listen to my presentation, and there's no point carrying on. Because if you're going to be closed-minded or stubborn, then you're never going to progress. The current theories cannot be accurate, all of them. For example, the Big Bang Theory doesn't use consistent physics. It's not possible to use current day physics and believe in the Big Bang Theory. It's not possible for light to travel at the same speed for everything, or there's no current theory that explains it. There's no current theory which explains how gravity works. There's so many gaps in our system that there cannot be a single theory which agrees with every current theory already out there. Anyway, if my theory is in any way inconsistent with the current theories, then I will look up the phenomena and facts that we use to come up with that theory. Using my theory, I'll explain why we observe those facts and phenomena. I will then demonstrate how my theory also follows these facts and phenomena, and finally I'll explain why the current theory appears correct but may be inaccurate or inconsistent. Alright? So, in summary, I have a single theory. It is simple. It uses current, proven, reliable, replicatable physics, and it explains all observable phenomena in the universe without exception. It does not agree with current theory and current theories which are out there, but if it disagrees with any of those theories, then I will break down the current theory, explain why we believe that theory to be true. I'll explain why we observe all these current phenomena that made us come up with this current theory, and then using my theory I will explain why we observe those phenomena and how they relate to my theory, why they are formed, why we see them the way they are, and then demonstrate why our current theory may be inaccurate. Alright, so does that sound fair? I think that's a pretty big ask. So, if I cannot do everything that if I cannot do this, then I will admit defeat. I will state that my theory is not the unified theory and that my theory may be inaccurate. However, if I can do all this that I promise, and this is a big ask, then surely you must agree with me that this is a unified theory. Alright? So, if at any point you disagree with any of my slides, come back to the slide, find out whether I've done everything I've said I would, and if I haven't, talk to me, I'll explain it, and if I can't explain it, then I'll admit defeat. Alright, so what is this theory? Let's see. Let's start with a basic concept. Let's say we have a hypothetical area here. And in this hypothetical volume or area or space, we have particles. These are individual motionless particles in their simplest most form. They have their lowest form of energy, the energy of mass, and nothing more. There are no internal or external forces on these particles. There is no movement, no temperature. These are just simple, hypothetical, basic particles distributed throughout space. The only force acting on these particles is the force of gravity due to their mass. So, if these individual motionless particles have the force of gravity acting on them, then over time they will move together. And here we have them here. So we have previously motionless individual particles over time have come together due to gravity. So far so good? Good. Outside of our hypothetical space, there are other hypothetical spaces. They also contain hypothetical particles of mass. And the same process is happening to all of them. So as we zoom out, we see that we have other clusters of particles, and due to gravity, over time, these clusters of particles will come together to form a single solitary mass. This process is repeated towards infinity. So as we move out, further and further, we get more mass. That mass is affected by gravity, and over time continues to join into a single larger mass. This mass grows and grows and grows towards infinity. So, we have individual motionless particles that over time come together due to gravity to form a single mass. This mass, alright, so far so good, makes sense, no discrepancies, alright, let's move on. So, there's a second force. Initially the only force is the force of gravity, but as the particles are redistributed, a pressure gradient is created. A vacuum is created between the collection of particles and the surrounding empty space. The more particles that are displaced, the greater the force of the vacuum. So here we have our individual motionless particles distributed throughout a hypothetical space. The only force acting on these particles is the force of gravity, pushing these particles inwards and towards the centre. As these particles move towards the centre, they leave an empty space. So there's now an uneven distribution where the mass is central and outside of the mass is a remaining empty space. And that empty space now has a pressure gradient, or a vacuum, and that's represented by these outward arrows here. As the mass continues to move towards the centre due to gravity, the outward pressure distribution increases. We now have a positive pressure of particles in the centre surrounded by a negative pressure distribution of empty space around the outside. We have effectively created a vacuum, or a negative outward force. So, when the particles are evenly distributed, gravity is the dominant force. The particles are evenly distributed, so there is no pressure gradient. Here we have evenly distributed particles. The dominant force is gravity, pushing the particles inwards, and there is no, because the particles are evenly distributed, there is no pressure gradient or vacuum, and there is no negative force. As the particles become redistributed, the force of the vacuum increases. The greater the particles are displaced, the greater the force of the vacuum created. So here all our particles are now displaced. They've all been redistributed into the centre, leaving an uneven distribution of negative space or empty space outside. So we have a positive pressure of particles, a negative pressure of a vacuum, and so we have a pressure gradient between positive and negative. Alright, here's a quick slide. So here we have all our particles evenly distributed. Each particle, as represented on this mass graph, has a unit of gravity. So one particle has 1 unit of gravity, and the surrounding space has no negative pressure because it is evenly distributed. As one particle moves to another particle due to the force of gravity, then this mass now has the gravitational force of 2 particles. The force of gravity increases, but also an empty space is left behind. This empty space creates 1 unit of negative pressure, which is then evenly redistributed throughout the entire remaining empty space. Over time, because gravity is the greater force, all the particles of mass join together to form a single solitary mass. As all the particles have been displaced, there is now an uneven distribution of particles to empty space, and a pressure gradient has been created, or a negative vacuum. So here, now the force of gravity is 100 particles and has 100 units of gravity, whereas all the particles have been displaced, the force of the pressure gradient, or the vacuum, has now increased, and that's represented on this graph. As the gravitational force increases linearly as the graph as mass increases, the force of the vacuum increases exponentially and gets closer to the force of the gravity. So here we have a graph representing the gravitational force of an individual mass. As the number of particles increase, the gravitational force also increases. Here we have a graph showing the collective force of the surrounding vacuum. So, as the number of particles is displaced increases, the force of the vacuum increases initially slowly, but exponentially. So the more particles that are displaced, the stronger the force of the vacuum. If we put those two graphs together, we can see that initially gravity is the strongest force pulling the particles inwards, but eventually, over time, the force of the vacuum increases exponentially and catches up to the force of gravity. At a certain point, the force of the surrounding vacuum will be greater than the force of the individual mass of gravity. At this point, we'll transition from a contracting mass where all particles are moving together due to gravity to an expanding mass where all the mass is being pulled apart by the force of the surrounding negative pressure or vacuum. So, vacuum, gravity versus the vacuum. As the individual collections of particles grow, the individual force of gravity increases for each individual mass. As the individual particles are displaced, the collective force for all the surrounding vacuum increases. Gravity is initially the dominant force. As the particles are displaced, the force of the vacuum increases faster than the increasing force of gravity. Eventually, the force of the vacuum will be greater than the force of the gravity. This will cause the contracting mass to expand. So, as I said before, I can relate this all to real life scenarios. Let's use some examples here. So, imagine we have a pot, and this pot is full of boiling water or it's full of steam. We put the lid on the pot, and the steam is distributed throughout the pot evenly due to a pressure gradient. As the steam cools, so as the steam cools, the steam then condenses down to water. So we have as the steam condenses down into water, the particles move together and the water condenses, leaving a surrounding empty vacuum. This empty vacuum then adds a force onto our pot, and the lid is difficult to remove. So, is that what I said in my slides? So imagine we have a pot of boiling water. When the water is turned to steam, we close the lid. We now have a pot full of steam. The particles are evenly distributed and there's no vacuum. As the steam cools, it condenses into water. The particles decrease in volume and we are left with water at the bottom of the pot and a surrounding vacuum of empty space with a strong negative pressure. Alright, makes sense. So here we have a space or a pot or a vacuum with evenly distributed particles throughout. There is no pressure gradient in the pot, and so the particles condense down due to gravity to form a single solitary mass in the bottom of the pot, bottom of the vacuum, and we are left with a surrounding negative vacuum with a strong pressure. Alright. What about the reverse? So let's think of a scuba diver's tank as full of compressed air. There is a large pressure gradient outside the tank, a relative negative pressure compared to inside the tank. When the tank is open, the particles redistribute outwards, so the pressure gradient causes the particles to expand, and the mass of the air expands due to the pressure gradient. So here's our expanding mass. Here we have a scuba diver's tank full of particles of highly compressed air. Outside we have a lower pressure gradient where the air is at a much lower pressure, so there is a pressure gradient between the tank and the surrounding atmosphere. When we open the tank, due to the pressure gradient, the particles expand outwards and redistribute evenly in the available space. Simple concept, well known to almost all scientists. It can be easily replicatable in everyday scenarios. The expansion and contraction of mass is dependent on the inward and outward forces. If the force of gravity is greater than the contracting mass, so if the force of gravity is greater, then the mass will contract down. Here the gravity is stronger than the force of the surrounding vacuum and you get a contracting mass. If the force of the vacuum is greater, the mass expands outwards and you get an expanding mass. The balance of forces changes depending on the location of the mass. So, here we have a mass. If we look at the centre of the mass, the force of gravity is greatest in the centre. As we move away from the mass, the force of gravity decreases, and the further away from the mass we are, the less the force of gravity. The opposite is true of the surrounding vacuum. Outside of the mass, the vacuum is strongest. As we move inside the vacuum, inside the mass, the force of the vacuum decreases, and the force of the vacuum is at its smallest at the centre of the mass. Make sense? So here we have a graph showing the force of gravity and the distance away from the mass. So as we move away from a mass, the force of gravity decreases towards zero. The opposite is true of a vacuum. So here we have the force of a vacuum at 100%. and as we move inside the mass towards the center, the force of gravity, the force of the surrounding vacuum decreases the further away from the vacuum you are. If we combine the net force between the force of gravity and the force of the vacuum, we can see the pressure distribution. So inside the center of the mass, the gravity is strongest and the force of the vacuum is weakest. Therefore, the net force is strongest inwards and the force of gravity is predominant. Any mass will be drawn inwards due to gravity. As we move further away from the center of the mass, the force of gravity decreases and the force of the vacuum increases, and our net force begins to decrease towards zero, all the way up to the point where the force of gravity equals the force of the surrounding vacuum. At this point, before this point, all mass will contract down due to gravity. After this point, all mass will expand outwards due to the pressure gradient being greatest for the vacuum and the vacuum having the stronger force over gravity. So far so good. I hope I haven't confused too many people. I hope you're still with me. Let's go through our checklist. Let's see what we've done. So I have a single concept, right? The concept is that there is a force of gravity acting on mass. There is a force of a pressure gradient acting on mass. It's simple. It's just two forces and the distribution between those two forces. It follows basic proven science. We can easily replicate it. We see it when we boil a pot of water. We see it when we open a pressurized container or a scuba diver's tank. It's taught to basic secondary school students when they learn physics. There are no complicated extras. There's no undiscovered forces. We don't have any strings. We don't have any dark matter or dark energy. We don't have any alternative dimensions. We have simple, basic, proven physics explaining a simple concept. But what don't we have? Well, we don't have a unified theory. We have not explained anything about the universe. So, what does this have to do with the unified theory? The unified theory. I will use this concept that we have just described to explain every single phenomenon that we have observed in the universe. I'll use this to describe the shape, movement, creation of the universe. I'll use this concept to describe how gravity works, how light works, how time works, and how to explain what dark energy and dark matter are and how they work as well. I will use this basic concept to come together to form a unified theory which explains all observable phenomena in the universe. So, thank you for listening to my first video. This is video 1. I appreciate it that you've got this far. If you're interested, if you think there's something going on here, then come and join me on video 2. I've entitled this video The Universe. I'll talk about how the universe was created, why the universe is expanding, the shape and distribution of mass through the universe, and the movement of the universe over time. So I hope you're interested. Please join me, and I'll answer a lot more of your questions in the subsequent videos. Thank you.